Welcome back. This is Frederick from Tektronix. Today we're going I did a few video here, try to explain a little bit of some of the confusion you can see in the industry is how we look at things like noise versus this versus that. Just, I work for tech, so I just wanted to make this very clear. So we always been using what we call 10 divisions on screen. So if you have 10 millivolt per div times 10, it gives you 1 volt. It's very simple. And the latest, things that we had about this is we're going to try to compare noise. And we try to use something that we call percentage of full scale, which means if you have a signal on screen which is 1 volt, compared to 1 volt, how much of that is noise? And other vendors try to look at it from a different perspective. I'm not sure if it's right or wrong, but full scale is something that we can look at. So a tech scope with 100 millivolt per div will give you 1 volt. Versus some other competitors, they have 100 millivolt per div, it will give you 800 millivolt. So that's something that you can recognize and think about how the industry compare itself. Of course, there's a difference between 1 volt and 800 millivolt. The second thing I would like to do is to show you, the difference between 8 and 12 bits. This is also something that is going to kind of in the same sense. It's a little bit strange how we do this. Why would we care about number of bits and the E-knobs? I will not go into the discussion about E-knobs today. I will do it from the perfect world. And if you ever looked at the specification from an analog to digital converter, there's no perfect world. But the 8-bit transforms into 256 quantization levels. And if you divide it by 10, as we have 10 divisions, each of these division lines will give us 25% discrete levels. And if you have 10 or 12 bits, you have more. And if you look at this, I'm trying to make a point out here is that each of these kind of bins or kind of divisions on screen, try to draw one really nice there, you can divide it by, so in the other case of 10 bits, we have 102.4, and in the last one, you can't see it, but it's 409.6. This gives you, in this case, when we have 1 volt full scale or 100 millivolt per div, it will give you approximately 3.9 millivolt as the best resolution. That's actually the step size. And the 12-bit, of course, will give you much more. At 1 volt full scale will give you less than a millivolt. I think it's 0.25 approximately. So these are the things you want to do is that. And why is it important? In some cases, you would like to monitoring a small signal in presence of a large signal. And that's all for me on this simple video about how to read scopes. Next video, I will go into some real hardware stuff. I actually have an LP, low profile scope I wanted to test.